Welcome back everybody to my object-oriented programming course using Java. Today we're going to talk about abstract classes. Abstract classes. And abstraction, if you know from the word, it means high level, right? If you're looking at concrete, that means we have more detail. In object-oriented programming, sometimes you may want to hide certain details and you only really want to show some type of essential information to whoever is going to inherit from your class. So abstraction really goes together with inheritance. It doesn't make sense to make a class abstract without thinking inheritance. Okay, so here let me show you a quick example of what we're trying to design. So let's say we want to design an application that's going to represent different shapes, right? So you're going to have a rectangle, you're going to have a triangle, and maybe you're going to have a circle. Okay? So actually let's make this a little bit bigger because rectangles are not like that. Let's rectangle like that. Okay? It doesn't make sense for me to represent a shape as one of these entities, right? They're all shapes. They're all inherit from a shape, but it's really useless for me to represent an actual entity as a shape. But we can say that all these are classified, right, as some type of shape. Right? We can just say something like shape up here. Okay, so now if you haven't looked yet, you know where I'm going with this. We're gonna do some type of a little bit of inheritance, right? We know that every shape has a number of sides, so we're gonna go with that. Okay, there's a lot of other stuff that a shape can have in common, but one of the basic ones is that all shapes are gonna have a number of sides. Even if it's a circle, you're gonna have 0 for the number of sides, right? So if I was creating a classes for this, okay, I'd start out with the shape class first on top, right? So I'd have a shape class. And then anybody that wants to create an extension of a shape, meaning an actual representation of a shape, then we'd create a concrete rectangle class. So we can say that this will be rectangle. And then over here we could have a triangle class. And then anybody that wants to represent any shape concretely, right, would create their class accordingly to whatever shape that they want. So hexagon, octagon, and etc. Now, if I was to look at this from an object-oriented programming point of view, I want these to be able to be instantiated. So I want this to be in memory. I want this to be in memory. But I don't really need anybody to have this here in memory. Why? Because it really has no use. I mean, you really want a concrete representation of a shape. You don't really care about the idea of a shape, right? We know that a rectangle is a shape. We know that a triangle is a shape. So a shape is an idea, right? And when you have something in terms of the relationship that it is an idea, okay, then the idea itself does not need to be an object, or actually doesn't need to be an object or instantiated as an object. So how do we get around this, right? Well, here's where abstract classes come in. Okay, and we can use the same concept with animals as well. Okay, and there's a lot of examples on Google about being an animal, and then each individual animal is a class. Well, we'll use shapes in this example. Now, by me marking this class as abstract, I'm doing a couple things. Okay, the first thing that I'm doing is I'm restricting this class from being able to be instantiated, which means that anybody that is going to want to use the shape class cannot instantiate an object out of a shape class. So what does that mean? I'm not able to do this anymore. So let me move this a bit. I'm not able to do shape s is equal to new shape. It's not allowed because I marked it as abstract, because it is an abstraction, right? It's a high level representation. We really don't need a concrete representation of a shape because we have different concrete representations of a shape. Okay, so we can't do that if it's abstract. Okay, what I also did is that I made it now inheritable, meaning that we can use this shape class to be inherited from. Okay, and we're going to do that in a little bit. And by me making this class to be inherited from means that everybody that inherits from this class must override anything else inside the class that's marked abstract. So in this case, the method that I'm marking as abstract is number of sides. Why? Because every shape is going to have a different number of sides, right? So at a high level, the abstraction part is, in general, every shape is going to have number of sides. They're all just going to vary, right? So I want every child class of shape, meaning that if we go back to our drawing here, so the child class rectangle, triangle, or octagon, or circle, when they inherit from shape, they are going to have to override that number of sides class and give their own concrete implementation. Okay, so anybody that inherits from shape, because this method is marked as abstract, is going to have to define and override this method here. Now, with an abstract class, you can mix and match, meaning that you can have abstract methods and then you can also have concrete methods, meaning that we can think of an abstract class as an incomplete class, where the completion will take place in the inherited child class for its own details for that child class. So, for example, let's say I want to create a rectangle class. So we'll create a rectangle class here. So we have a rectangle class that extends shape, right? We're going to define a number of sides, just a variable final, okay? Because you know that number of sides will never change, okay? Now, we're defining this as 4, and now here we are overriding the number of sides method, which is the abstract method of the parent class. Now, what does that mean? It means that when I mark this as abstract, any child they're forced to override this method. With description, they're not, because it's not marked as abstract. So if I have another class, let's say I have a circle class and I forget, or I don't really want to define the description, then it's going to fall back to the abstract class method description, and it's just going to say I'm a shape. Okay, so you can have a mix and match, but it's still considered, so the abstract class shape is still considered an incomplete class. So that's why it's called abstract, because it's an abstraction. Okay, hence, because it's incomplete to the Java compiler, you cannot instantiate an object of an incomplete class. The Java compiler is going to say, this is incomplete, so I cannot create an instance of you. I cannot create an instance of you. Hence, that's why we have a rectangle class, which is the concrete representation, okay, of this abstraction, right? A shape is an abstraction. Rectangle is a direct concrete implementation of a shape. And then here I redefine the method and I return the number of sides. And I just have a description here. So if I go to main, when I create my rectangle method, that's all in good, because rectangle is a concrete class. It inherits from abstract, and then I just call the description method, and voila, I'm able to use my rectangle class, right? So I'm a rectangle. Okay, and then if I called the number of sides method, it's going to call the obviously the concrete implementation, right? It's never going to call the abstraction. Okay, it's not going to call the abstraction. Now, if you mark a method as abstract, you must make the whole class abstract. You can't have you can't have a methods that are abstract, because the compiler is going to get confused and say, hey, we know that this is an incomplete method, right? If this was abstract and this is not abstract. So once you define one method as abstract, the class itself must be marked as abstract. Now here's another thing that I want you to be aware of. So I can declare an instance of rectangle, but I cannot declare an instance of shape. So if I did the following, so shape is equal to new shape. Okay, if I did the following, that is actually going to throw an error because shape is abstract. Okay, so let's try this here. So see the file, H in the file. Okay, so end the file while parsing. Yeah, so that's going to give us an error. Okay, sorry, I had a missing bracelet. So here you see the shape is abstract. It cannot be instantiated. But here's a little caveat though. Okay, here's a little caveat. We can have an abstract type and point to, we can reference an object of the concrete implementation. Let me show you how that's done. So because an abstract class is really a type, okay, you can consider it a type, we can have it be a reference type, and we can new up a concrete type, and that's allowed. We're allowed to do that. And by doing that, that means that this shape, which is an abstraction, is able to point to any child that's a concrete implementation. So by me newing up a rectangle, again, this is a concrete class, and then I can, and this is now an object of the shape class, but again, shape is a type. Okay, shape is a type. So S would be, the reference type would be shape, but it's an object of rectangle. So that's why when we run this, you're going to see that it's going to call the number of sides. It can't call the abstract method, right? So here we go. It can't call the abstract method of shape, because we know that an abstract method is going to be an incomplete method. So S dot number of sides is going to be this, right? So now the question arises is, what about the description method, right? So if I call the description method, because it's the reference type is shape, is it going to call here the abstract method, which is defined, or is it going to call the rectangle method? So you got to remember who the object is. So it's an object of rectangle, right? And because rectangle does have an overridden method of description and implementation, then it's not going to use a shape description. It's actually going to use the rectangle because it is an object of that class. Okay, so visually, okay, let me just see something here. Visually, the way we look at it, here is the shape class is actually, we can consider it a type. And when we create the shape S, which we're doing in our code here, real quick, right? We're actually pointing to an instance of rectangle object. So this is actually visually how what's happening is, when we did a new rectangle, we created an object in heap memory, right? And the type of S, so we'll call this variable here, the variable S, the type of S is shape. That's its data type, or reference type. But the object that it represents is a rectangle. It's in concrete implementation, right? So remember, anything that you need to instantiate has to be concrete. It's got to be created in heap memory. And then only then can we access the concrete implementation's methods and any instance variables are available to us, right? And because and again, this is only works with inheritance because rectangle is a child of shape, right? Then that means that we can use that as a reference type. If rectangle was not a child, so let's say I created, I'm not allowed to do this. I'm not allowed to create an instance of dog. Let's say I had a dog class, right? And I try to use the reference type shape, right? And assuming that dog does not inherit from shape, it shouldn't, right? Because dog is not a shape, it's an animal, right? So if I did something like shape s is equal to new dog, there's no relationship here, right? A dog is not a shape, but a rectangle is a shape. So you got to remember that keyword, is a. Is a dog a shape? No, it's not. So it can't have a reference type. So you can't do this. It's not allowed. Okay? It only works when there is an inheritance chain when you're talking about abstract classes and using an abstract class as a type. Okay? Okay, I hope that cleared up a lot of misconceptions or confusion that you had about an abstract class. And on the next video, I'm going to start talking about exception handling, okay, in our code, which is very, very important topic. Okay? Okay, I'll see you on the next video.